Good to see you. I'm really looking forward to learning more about you. Let's begin our interview.
Great. I'm excited to dive in. Feel free to hit me with any questions or scenarios you have in mind, and I'll do my best to tackle them.
Perfect. So today I'm going to throw a probability and strategy question your way. It's actually a fun casino-style game scenario. It involves some decision-making under uncertainty, which I think you'll find interesting. Let me set this up for you. In this game, you have a 20-sided die, so a die with the numbers 1 to 20 on the faces. At the start of the game, it's on the table, and the one face is facing upright. Now you're going to have 100 rounds, and in each round, you have two options. You can either roll the die, replacing whatever it's currently showing with a new number, or you can take a number of dollars from the casino equal to the current face. Are you following so far?
Yep, I'm with you. So I get to choose each round whether I want to roll again and maybe get a higher number, or I can just take the amount of dollars showing on the die. Sounds like it's going to be a fun challenge to figure out the best strategy.
Exactly. And just to clarify, when you take money, the game doesn't end. You still need to go through all 100 rounds, so you could potentially take money multiple times throughout the game. So my question is, how would you play this game intuitively, and how much money do you think you'll make on average?
That's a really interesting question. Intuitively, I'd probably want to roll the die whenever the number showing is low, like maybe if it's under 10, to try to get a higher number. And if it's a high number, like in the mid-teens or higher, I'd probably take the money. On average, the expected value of a roll is about 10.5 since it's a 20-sided die. So I'd guess that over the course of 100 rounds, you probably end up with something a bit over $1,000 if you play it smart.
That's a reasonable starting intuition. You're right that the expected value of a single roll is around 10.5, but let me push you a bit further. What if you were more aggressive with your strategy? Like, what if you kept rolling until you hit something really high, say a 20, and then just took that 20 for all the remaining rounds?
Oh, that's a fun approach. If you keep rolling until you hit a really high number like a 20, and then you just cash out that 20 for all the remaining rounds, you definitely maximize your earnings. It might take a few rolls to get there, but once you do, you're guaranteed that top payout for the rest of the game. So that could definitely increase your average earnings even more.
Good thinking. Let's get a bit more specific with the numbers. If you're rolling until you hit a 20, how many rolls do you think that would take on average? And then what would your total earnings be?
On average, since there's a 1 in 20 chance of rolling a 20, it would take about 20 rolls to get that 20 on average. Once you do, you'd lock in that $20 for the remaining rounds. So if you spend about 20 rounds rolling and then you have 80 rounds left at $20 each, that would give you about $1,600 total on average, which is pretty awesome.
Exactly right. $1,600 from that strategy. Now here's an interesting question. What if you were a little less strict? Instead of waiting only for a 20, what if you accepted either a 19 or a 20? How do you think that would compare?
That's a great twist. If you accept a 19 or a 20, then you have a 2 in 20 or 1 in 10 chance each roll of getting one of those numbers. That means it would take about 10 rolls on average to hit either a 19 or a 20, and then you'd lock in at least $19 for all the remaining rounds. So if you spend about 10 rounds rolling and then have 90 rounds at least $19 each, that would give you around $1,710 on average, which is even better.
Nice calculation. You're getting the hang of this. Just to clarify though, when you get either a 19 or 20, what's the average value you'd expect to lock in?
That's a good point. If we're accepting either a 19 or a 20, then the average of those two numbers would be 19.5. So once you hit that threshold, you'd be locking in an average of $19.5 for the remaining rounds, which is still a great improvement.
Perfect. So with that correction, what would your total expected earnings be with the 19 or 20 strategy?
All right, so if we're aiming for a 19 or a 20 and it takes about 10 rolls on average to get there, then we have 90 rounds left at $19.5 each. That would give us about $1,755 in total, which is a nice boost compared to just waiting for the 20 alone.
Excellent. So you found that being a bit more flexible actually increases your earnings. What do you think happens if you extend this even further? Say, accepting 18, 19, or 20?
If you expand it to accepting 18, 19, or 20, that gives you a 3 in 20 chance, or 1 in about 6.67 rolls on average to hit one of those numbers. The average of 18, 19, and 20 is 19. So once you lock that in, you'd have about 93 rounds left at $19 each. That would bring your total expected earnings to about $1,807. So being a bit more flexible definitely seems to pay off.
Good reasoning. Just a small correction on the math. If it takes about 6.7 rounds to hit one of those numbers, you'd have about 93 rounds remaining. And at $19 each, that gives you about $1,773, which is still better than the previous strategy. Now, here's a key question. Do you think this pattern of expanding your acceptable range will keep improving your earnings indefinitely?
That's a great question. Eventually, as you expand the range of numbers you're willing to accept, you'll start locking in lower averages, which can reduce the overall earnings. So there's definitely a sweet spot where you're balancing the frequency of hitting those numbers with the value you lock in. Expanding the range infinitely won't keep increasing your earnings forever, because eventually you'll be accepting numbers that are too low to really maximize your total.
Exactly right. You've hit on the key insight. There's a trade-off between how quickly you lock in a number and how high that number is. Now let me ask you this. Is this strategy of wait for numbers in this range, then always take money universally optimal? What if you're really unlucky and you roll until round 99 without hitting your target numbers?
That's a really good point. If you get really unlucky and you keep rolling without hitting your target numbers for a long time, you might miss out on a lot of potential earnings. So while this strategy is generally a strong approach, it does rely a bit on probability and luck. In some cases, it might be better to settle for a slightly lower number just to avoid that risk of being stuck rolling for too long. So it's definitely about finding the right balance.
You're on the right track, but let me be more specific. Imagine you're at round 99 and you still haven't hit your target range. You have one round left. What should you do in that final round?
Got it. If you're at the very last round and you still haven't hit your target number, at that point, it would definitely make the most sense to just take whatever number is currently showing on the die. Since there's no more rounds left to roll, you want to make sure you at least cash out what you have rather than risk getting nothing.
Exactly. So, if the optimal strategy changes in the final round, what does that suggest about whether this wait for 18, 19, or 20 strategy is truly optimal throughout the entire game?
That's a really insightful point. It shows that the optimal strategy can actually shift depending on how many rounds you have left. Early on, it makes sense to be a bit more selective and wait for those higher numbers. But as you get closer to the end of the game, it might be smarter to adjust and be less strict so you don't risk missing out entirely. So the strategy evolves a bit as you go through the game.
Perfect. You've really grasped the core insight here. The optimal strategy does indeed depend on how many rounds you have remaining. Early on, you can afford to be picky and wait for those high numbers, but as time runs out, you need to be more flexible. This suggests that to find the truly optimal strategy, you'd need a more sophisticated mathematical approach. Something like a recurrence relation that could tell you the best decision at each step based on how many rounds are left. Nice work thinking through this problem. That was exactly the kind of reasoning I was looking for.
Thanks so much. It was really fun to think through all the different angles of that scenario. It definitely shows how nuanced probability and strategy can be. I'm glad you enjoyed the reasoning process, and I'm definitely ready for any more questions you might have.
Great. I'm glad you enjoyed working through that one. You really showed solid intuition about the trade-offs and how the strategy should evolve. That was actually the main question I had prepared for today's session. You covered all the key insights really well, from the basic strategy of waiting for high numbers, to optimizing the threshold, to recognizing that the strategy needs to adapt based on remaining rounds. Shall we wrap it up here?
I'm really glad you enjoyed it. It was a lot of fun working through that scenario with you, and I'm happy we covered all the points you had in mind. If there's nothing else, I'm totally fine wrapping up, but if you have any more questions in the future, I'm always here to help.
Perfect. Thanks for such an engaging discussion today. You really demonstrated strong analytical thinking and adaptability with that probability problem. Have a great rest of your day.
Thank you so much. I had a great time adding with you too. I really appreciate the kind words. Have an awesome day.